Good day everyone, my name is Xiang and I'm a third year student from software engineering. So today I'm going to present my final year project 1, which the title is Ontology-based medical history management system. Okay, so let's get started. Okay, based on the Department of Statistics Malaysia, there's a total of around 550,000 traffic accidents that happened in 2018, and 1.1% of them involve deaths, which results in 150 accidents per day. And the failure to retrieve an injured person past medical history has increased the rate of fatal. So when an accident happens, before the first aid of stabilization is applied to the injured person, it's dangerous because the medical history of the person remains unambiguous and the patient might be allergic to certain medicine. Currently, most of the people's medical history are stored within a decentralized database of certain organization, and we are now lacking of a centralized system to store people's medical history. And also, the transportation of injured person to the accident and emergency or A&E department takes time, and it might be too late when the condition of injuries is to be analyzed after they reach the hospital. So hereby, I propose to develop an ontology-based system that utilizes a centralized ontology, which allows users to perform, create, retrieve, and update operation in order to manage the people's medical history. Besides, a real-time communication between the paramedics and also A&E unit physician can be done through the system. I will talk a little bit about what is ontology. So ontology enables the modeling of knowledge, and it consists of a set of axioms which describe the structure of a model, which is analogous to database schema, and also facts, which describe the particular statement, which is analogous to database data. One of the most important concepts of ontology is open world assumption, where we treat missing information as unknown rather than treat them as fault, which we use in the closed loop assumption in the conventional database. Besides, axioms behave like implications, and we can obtain explicit information using inference rule in the ontology. So why ontology? Ontology is suitable for large and complex schema because of its ability to inference. We can derive new information from existing information rather than looking up the data. But it has a drawback, which is a high worst-case complexity. But by reducing the inferencing, a larger scale system can be reached. Besides ontology, the technology that I have used is Angular Framework and also Model View Controller MVC. For Angular Framework, it provides a neat modular structure to create web application, and also it promotes code consistency. It has some features such as two-way binding, templating, modularization, RESTful API handling, and so on. And with these features, we can use less third-party libraries. For the MVC, we can have a clean separation of user interface, business logic, and also model. And the code will be easier to maintain using this design pattern. Okay, now we'll compare some existing system on the market, which is OSP Labs, Henry Schein MicroMD, and also road accident management proposed by Xiang. As you can see, all these three systems, they provide the features, which is the electronic data management, real-time data access, and also real-time data sharing. For the safe data storage, secure data storage, EHR EMR integration, which is electronic health record or electronic medical record integration, OSP Labs and Henry Schein MicroMD provides this feature. Okay, so for the image management and annotation and user roles to limit access, we can know that Henry Schein provides this feature. And for the road accident management proposed by Xiang, a recovery plan, location awareness, and implementation of ontology is provided. The methodology that I have chosen in this project is the Agile methodology. It has incremental and continuous iteration of development and testing, and thus it is very flexible, and also it allows implementing regression testing. And here are all the phases of the methodology, which includes 6 sprints. And the first sprint is requirements gathering, followed by the system design. And also we have 3 modules in this project, which is the module user, module emergency, and also module medical record management. And they are included in the sprint 3 to sprint 5. And in the last sprint, we will have the oral testing. Okay, so the technology used for software includes Visual Studio Code, Angular Framework, Google Chrome, Prodigy Desktop, and Firebase. For the hardware, I'm using laptop with the operating system Windows. And since we don't have a stakeholder in this project, our requirements are all elicited from general paper, which is the road accident management proposed by Xiang, and also two existing systems, the OSP Labs and Henry Schein MicroMD. This paper and existing systems are researched, compared, and analyzed to get the requirements that fit in my project. And now we'll look at the use case diagram according to the three modules. So in this module user, we can see that there are four actors here, which are the paramedic, medical receptionist, any unit physician, and also system admin. So all the users can perform the use case login, and system admin can perform the use case register user and also manage user. For the module emergency, we have two actors here, which are the paramedics and also A&E unit physician. They both can search for person and also view medical history. Paramedic can perform the use case send injuries detail, and the physician can view injuries detail sent by the paramedic. In the last module, we have our medical receptionist as the actor, and they can search for person and view medical history, update medical history, and also insert medical history. Okay, now let's move on to the non-functional requirements part of my system. And here are all my non-functional requirements. So the first one is security. It ensures unauthorized user is unable to access the system, and also the roles of users restrict them to access certain pages. So for the portability, it allows users to access the system in different kind of web browsers. For the usability, it allows users to perform the functionalities with less mouse clicks and also keystrokes. Availability will ensure the system is up and available to the user most of the time. Last but not least, maintainability will allow the system to be managed, corrected, modified, and updated at ease. So this is my component model. As you can see, there are two sides here, which is the client side and also the server side. On the client side, we have our web application, and AngularJS is used as the front-end framework, and HTML, CSS, and TypeScript are used to support it. And when the client side send requests to the server side, we have the Firebase backend as a service, and Firebase will perform CRUD operation on the Firestore and also the Ontology-based. And after that, it will return with a response back to the client side. This is the entity relationship diagram of my project, which it consists of two tables, the user and injuries detail. And here are all the properties of both of the tables. We have two ontology diagrams, which are the disease and allergy, and also medical record. As you can see, medical record here is a parent class, and disease name, date, disease detail description, and allergy type all belongs to the medical record. And heart attack, diabetes, and so on are type of disease name, and also allergy on this type of medicine and drugs is type of allergy. For the medical record, we can see that person is a parent class, and NRIC and medical records all belong to the person, and accident can happen to a person. So road accident or fire accident is a type of accident. So this is the interface design of managed user page, where simple minimalistic design is applied to increase the usability and attractiveness of the system. So last but not least, this is the site navigation diagram of the system, where we have a login page at the start, and then we can have different main page for different type of users. And then the users can perform different types of operation by navigated to their corresponding page. So this is the overall site navigation diagram. Okay, so as a conclusion, my proposed system is able to reduce risk and fatal rate of accident. Because when the medical history is known prior, the physician and also the paramedics can make a better decision and perform a better operation to help the injured person. Besides, this system will improve the communication between the paramedics and any unit physician, and this can save up the time for the physician to analyze and make decisions. The time saved up might be very important to the injured person, because as we know, every second is very important in saving lives. So that's all for my presentation. Thank you.